Rekhat structure is a giant formation in the Sahara that looks exactly like a giant bullseye. It's so wide that you can see it from space. Even the CIA got interested in it. In 1965, they planned a flyover looking for geomagnetic anomalies. The findings are still classified. Perhaps the theories are true, and this place is truly the lost city of Atlantis. Now, Atlantis supposedly sank beneath the waves, but recent discoveries are pointing us in a different direction. This is an ancient story that goes far back in time, and Plato was the first to mention it. The place had loads of greenery and a curious structure: 3 concentric circles of land surrounding 2 circles of water. 2 key quotes from Plato's writing suggest that Atlantis might not have been a typical island in the middle of the ocean. Plus, Atlantis had a major influence from Africa and Europe, challenging the idea of it being in the Atlantic. It turns out that the Eye of the Sahara and Atlantis look alike. When astronauts saw the Eye of Sahara from above, they initially suspected a meteorite impact crater, but the rings of the structure matched the layout described of Atlantis. More importantly, the Sahara wasn't always a desert. It turned from a tropical region into a desert around 11,000 years ago. Researchers found evidence of a massive river called the Tamaracet that could have sustained a community. This river flowed toward the Rekhat structure, aligning with Plato's description. The Trans-Saharan Seaway ran through the Sahara 50 to 100 million years ago. The sea allegedly destroyed Atlantis around 11,500 years ago, likely due to a rapid rise in sea level caused by the end of the Ice Age. NASA's worldview imagery shows patterns consistent with this theory. Those concentric rings might be a key to unlocking the secrets of our planet's evolution over millions of years. They're shaped by erosion on resilient rock layers, creating a spooky pattern of ridges and troughs. The central peak stands proud at 1,300 feet. The central part has undergone a significant erosion makeover, revealing a circular structure with a raised peak. Unlike impact craters, the Eye of the Sahara flaunts a striking balance and symmetry. Some say it results from rock uplift, sculpted by wind and water. Others think it's an ancient anticline, eroded to reveal its concentric glory. Then there's a salt diapir theory, suggesting that salt's buoyancy sculpted this beauty. Dating techniques have proved that it formed 541 to 252 million years ago, give or take a million or two. Ancient tools are scattered around the outer rings of the structure near riverbeds. Some older stone tools have also been spotted in the same areas. And still, even though some spear points from the Neolithic period have been found, there aren't many signs that people were living there back then. The area seems to have been used for short-term activities like hunting and making tools. There are other unearthly mysteries that haunt our world. One such enigma is in Norway: the ominous Hessdalen light phenomenon, also known as the Valley of Lights, leaves scientists confused. This valley is 10 miles wide. It's quite isolated, but a peculiar blue box sits high on the hillside, equipped with cameras scanning the valley. The unsettling saga began in the 1980s, when the night sky over Hessdalen erupted with burning fireballs, a recurring spectacle that sent shivers down the spines of those who witnessed it. This wasn't a fleeting occurrence, rather it became a regular thing. Terrified locals reported encounters with these unexplained luminous phenomena, some of which happened near their homes. Unease spread like wildfire. At its peak, there were about 20 sightings every week. The phenomenon made its way into newspapers, magazines, and media worldwide. Soon, people flocked to the valley, hoping to see the lights themselves. In 1984, experts joined the fray, armed with sophisticated instruments like magnetometers, radiometers, and other ometers. What they encountered was mind-bending, lights that defied explanation. Some moved at a leisurely pace, while others raced through the sky at an astonishing 19,000 miles per hour. People tried to explain these lights: airplanes, distant reflections, ball lightning, satellites, planets, meteors. But the speed and how these lights danced ruled out all those theories. We're slowly approaching another mysterious place. This is the greatest subglacial lake among Antarctica's 675 known lakes. It can easily hide unknown life forms. This lake is beneath the East Antarctic ice sheet. Dive about 2.5 miles under the ice, and there you'll see Lake Vostok, located at 1,600 feet below sea level. This lake is 155 miles long and 31 miles wide at its broadest point. With an average depth of 1,400 feet, it's also the world's sixth largest by volume. It's like an underwater city with lofty pillars and deep basins. The secret lake was discovered in 1993, yet it had been waiting to be found down there for over 2,000 years, collecting ancient secrets. In 2012, scientists drilled through the ice, creating the longest ice core ever. They pierced the ice all the way to the lake's surface. The year 2013 brought an unexpected twist when the tranquil waters erupted during the extraction of an ice core, mixing with drilling fluids. Then they got a pristine water sample in 2015. Some believe there might be previously unknown life forms down there, since it's a fossil water reserve that's been untouched for millions of years. That could be a lot like those speculated ice-covered oceans on moons like Europa and Enceladus. It all started with a theory in the 19th century, suggesting fresh water lurking under Antarctic ice sheets. Then, in 1955, seismic soundings hinted at a subglacial lake, and by the 90s, satellite data confirmed Lake Vostok's existence. Now, Lake Vostok isn't alone. In 2005, they found an island in the middle of the lake. Then, two smaller lakes joined the party. They suspect that a secret network of subglacial rivers might link these lakes. Now, very far away from Antarctica, in Venezuela, Catatumbo lightning presents a sinister light show at the junction of the Catatumbo River and Lake Maracaibo. This unsettling lightning phenomenon happens at about 140 to 160 nights a year, going on for 10 hours a day, and can flash up to 280 times in a single hour. The frequency of this lightning show changes with the seasons and from year to year. There was a break between January to March in 2010, causing a bit of worry that it might vanish forever. As the sun sets, winds from the east start picking up speed. The strong wind is called a nocturnal low-level jet, like what you see in the Great Plains of North America. These winds bring moisture, mostly from the Caribbean and the lake itself. This humid air hits high mountain ridges, causing thunderstorms to form over the mountains. Thanks to the ongoing wind situation, more thunderstorms appear as the night goes on. This pattern repeats itself, and is why this area has the highest annual lightning rate globally. The next place scientists cannot explain is in China. That is the Longyou caves. They have lofty slanted roofs and sturdy pillars. The spot remained hidden for centuries. These human-made caverns, built around 2,000 years ago, decided to reveal themselves only in the 90s. Local farmers drained some ponds and unveiled 5 massive caverns. Further digging exposed an additional 19 smaller caves. They range from 60 to 110 feet in width and 26 to 50 feet in height. Archaeologists found historical relics from the reign of Emperor Zhuan of Han, dating back to over 2,000 years ago. Now, how did these caves survive for more than 2 millennia without falling apart? No ancient records explain the way they were crafted either. The walls show chisel marks, hinting at some layer-by-layer chiseling action, but the exact construction process is still a head-scratcher.
You decide to go out for a morning jog for the first time in your life. You put on your headphones and get ready for something hard and unpleasant. But as soon as you go outside, you feel an extraordinary lightness. At first, you enjoy it and speed up, but then you realize that something's wrong. You're running too fast and too easily. You feel like you've just taken off a heavy backpack that you've been carrying all your life. You're so fast, you think you must have a superpower now. But you notice another athlete running as quickly as you. You notice a puddle ahead of you and jump over it. You jump so far and so high, it feels physically impossible. You fall to the ground, shocked. Then you notice there are no scratches on your body, and the ground feels lighter. You stop the music in your headphones and turn on the radio. All the news reports say the gravity on the entire planet has decreased by half. Thanks to gravity, we stand on the ground and don't fly away into the sky. This power allows our planet to revolve around the sun, and the moon to revolve around us. Heavy things seem heavy because of gravity. And now, something has happened to the Earth's core, and the mass of our planet has decreased. This is the reason for the change in gravity. People happily run out of their houses and jump twice as high and further than they used to. Any objects seem twice as light to you. Your body has become lighter, so you can easily stand on your hands. But still, you don't feel like a superhero. You can't lift a car, even if its weight was reduced by half. But now, parkour is easier for everyone than before. Your body's weight has decreased, which means you get less damage when you fall. However, panic quickly replaces the joy of the new conditions. It becomes hard for you to breathe, the same as all other people. The air has become lighter. The updated force of gravity has reduced the air pressure by half. Now you feel like you're at an altitude of 16,500 feet among the streets of a usual town. It's like you're halfway to the top of Mount Everest. The air is no longer as dense, and the main part of it has settled in the atmosphere. In the beginning, everyone experiences massive dizziness and panic. You feel like there's not enough air in your lungs, so you get nervous. To solve this problem, you have to learn to breathe slowly and evenly. Thanks to this, you calm down a bit. Others also learn to be more balanced and don't live in a hurry anymore. All of you experience less stress and enjoy every day. Then scientists create unique oxygen masks. You put it on, take a breath, and a special filter puts pressure on the oxygen molecules, making the air denser. After a couple of decades, people will take off these masks as they'll ultimately get used to the new conditions. New generations will be born with adapted lungs. The Earth's atmosphere is expanding. It seems the sky has risen higher and acquired a darkish hue. Satellites flying around the Earth's orbit are now inside our atmosphere, but the Earth's gravity still attracts them. You see thousands of satellites burning up. Some of the space debris survives the atmospheric shield and falls to the ground. A meteor shower begins. Space trash crashes into houses, roads, trees, and cars. You and the rest of the people decide to wait out the storm underground, in the subway or basements. Fortunately, the shower doesn't last long. People come out of their hiding and look at the sky in surprise. The moon changes its previous position and slowly flies away. Soon it disappears completely. Our planet is now like a heavy ball in the center of a huge blanket. That blanket is gravity. It bends under the ball's weight. If you put any light object on the blanket, it will roll down to Earth. But if an object is moving at high speed, it will be able to spin on the blanket's edge and not fall into the center. Thanks to such speed, the moon doesn't fall on us, but at the same time, it can't fly away. Now that gravity has decreased, the blanket has become twice as loose. The rotation speed allows the moon to fly out of our gravitational field. It just goes into space. People will be able to observe the wandering moon for a long time through telescopes. Meteorites might crash into it. It could also find another planet with stronger gravity and will revolve around this new home. The moon may stay in place, but will be revolving around the Earth at a slower speed. In any case, there will be no more tides on our planet, and the sea level will remain the same. In the sea, you can also feel the changes. It's much easier for you to stay on the water, and you can swim faster. But the coolest thing is running along the shore. The splashes are floating in different directions, so slowly and beautifully. The waves are running on the sand in slow motion too. The weight of cars, planes, and ships has reduced, and so people consume less gas now. You can drive twice as far with a full tank. Fuel transportation is easier, and less energy is spent on flights. Gasoline is becoming cheaper. The decrease in gravity inspires space tourism development. It becomes much easier for people to fly out of the Earth's orbit. Winter has come. You're walking down the street during a snowfall. It seems to you the snowflakes are stuck in the air as they're so slow. You step on the ice and realize that it's almost impossible to walk on such a slippery surface. Your weight has decreased, and the pressure of your feet on the ice is twice as weak. You're sliding and can't stop. You often fall, but you don't feel any harm. When the wind is strong, it's hard to stay on your feet. If you jump, you may even fly away. The grip of wheels on the road deteriorates. A driver can no longer brake abruptly. The wheels don't spin, but the car continues to slide for a while. That's why new speed limits are being introduced all over the world. You can still enjoy extraordinary strength and long jumps, but after a few generations, the human body will evolve and fully adapt to these conditions. People and animals will be born taller and bulkier. Majestic tigers the size of a truck are walking through the city streets. Flamingos the size of a plane are flying in the dark blue sky. But the worst thing is that the size of insects has increased too. A regular cockroach can now grow to be the size of a computer mouse, and tarantulas become twice the size of an adult palm. At the same time, all living beings become lighter in weight. Humans will become elegant and agile creatures. Our bones and muscles will stretch. The structure of the entire human body will change. We'll become thinner and smoother. Blood in the veins and vessels will flow more slowly, and it will greatly impair the brain's work, but only in the beginning. In the future, the body will expand. The brain will increase, as will the number of neural connections inside. The lungs will become more sensitive and spacious. People will be smarter and wiser. All devices and materials will be developed according to the new conditions. A cup, a pencil, a plate, phones, and other gadgets. Everything will get lighter and more fragile. If an ordinary person gets into such a world, they'll feel like a superhero. You'll be able to punch through lightweight walls and doors and break bricks with your hand. New people won't match your power, but you'll seem too small and clumsy to them.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things: how big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavyweight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, they're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity, the force that pulls things together, seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide and seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure, gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike.
Oh, gravity, you heartless so-and-so. Well, that's what I think when I trip over a stone and fall face down. Of course, I'm not clumsy, you know. Anyway, gravity is a constant, right? Something entirely unshakable that we can always rely on in this ever-changing world. Unlike, love. Feeling romantic, sorry. But what if I told you that it's not as honest and clear as you think? There are places on our planet where gravity behaves like it's gone crazy. And that's why you clicked here. So let's take a look. Magnetic Hill in Leh, India. There's a stretch of road in India that's been attracting tourists from all over the world. It's no different looking from the surrounding landscape, and you could easily pass it by without noticing, if not for one very unusual and a bit creepy thing. If you stop your car on the magnetic hill going up the slope and put it on neutral, it'll start crawling upwards, eventually reaching the speed of up to 12 miles per hour. They say there's some sort of magnetic force at work here that tugs cars up the hill hence the name. On top of that, even airplanes are said to gain altitude above this place. Skeptics offer another explanation, though. It's just the lay of the land that creates an illusion of going upwards, while in fact you're moving down the hill and vice versa. Whatever the truth, I'd like to see it for myself. Would you? Tell me down in the comments. The Crooked Forest, Poland. Near the village of Nowa Tarnowo, there's a forest in the depth of which you can find a strangely looking pine tree. Planted in the 1930s, there are 400 trees that sharply twist to the north almost at the roots, and then grow upwards in a semicircle. Although scientists offer different theories about the tree's weird growth, nobody can say for sure what made them look like that. Some say it's people who did it, while others believe it's a gravitational anomaly that somehow pushed the trees down. The trouble with this version, though, is that it would have had to stay there for years, and that only affected the trees. Still, no certain explanation exists anyways, so who knows? A waterfall, Faroe Islands. Ever seen an upward-moving waterfall? You can have a look at one on the Faroe Islands, halfway from Iceland to Scotland. But if you were expecting me to tell you an unbelievable story about a mysterious force pushing the water up the rock, then sorry, no such thing here. The truth, however, is quite jaw-dropping anyway. The winds in this place are so powerful that they lift the water and throw it back up. I guess it was this kind of wind that allowed Mary Poppins to travel on her umbrella. Sounds good. In fact, this waterfall is not unique. There are several more places on Earth where winds create an illusion of defied gravity. For example, there's the Kinder River in England that has a waterfall constantly struggling with the wind. It's so strong that half of the Cascades water seems to just fly up without ever touching the bottom of the drop. Hoover Dam in Nevada, USA. If you ever get up to the top of the dam, which is about 726 feet high, you can try a little trick. Take a bottle of water and pour it over the edge. You'll see the water flow up instead of spilling down. Once again, this isn't really any magic or unnatural phenomenon. The wind up here is simply too strong for the water to fall, just like with the waterfall on the Faroe Islands. Here though, it looks even more impressive since you can do it yourself. Dokkaebi Road, South Korea. Another gravitational anomaly located on a road. Locals once found out that if you put an empty can or a bottle on the ground, it will immediately start rolling uphill. Unlike other such places in the world though, Dokkaebi Road doesn't just create an illusion. When you walk down the slope, you don't feel as if you're going up. Everything's pretty normal. But once you put down an object that can roll, it will do that in the opposite direction than it should. Local authorities were quick to get the idea and put a signpost directing curious tourists to the mysterious road. Golden Rock, Burma. If you happen to be in Burma, these days it's also called Myanmar, make sure to visit this well-known site. A gold leaf-covered boulder sits upon the edge of a cliff, and a small pagoda is built on top of it. The impressive thing about the rock is that it only lightly touches the cliff for support. In fact, it looks like the boulder will fall any minute now, but it has been standing like that for centuries. On top of that, the pagoda built upon it is not really a recent addition, so it's quite an unusual sight to see. The rock seems to be saying, "Gravity? I don't care about that stuff." The legend has it that what keeps the boulder in place is a single strand of Buddha's hair. Well, I don't know about that, but you can check out the rock for yourself and see that it's not attached to the cliff by anything. And yet, it's not budged for 2,500 years. Something must be at work here, huh? Stone of Davasco, Argentina. If there ever was a thing that said, "I defy gravity" out loud, it's the Stone of Davasco. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately, today you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people in the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. Well, not exactly put it together chip by chip. They made a plastic replica of the rock and put it on the same spot and even in the same position. So even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Devil's Tower in Wyoming, USA. Remember this place from the movie Close Encounters of the Third Kind? If not, you should go watch it, but not right now. This place doesn't make you feel like you're witnessing some magic and doesn't really trick gravity right before your eyes. Sounds almost boring compared with the rest of the sites on my list, right? But the true mind-blowing feature of Devil's Tower is that scientists can't explain how it came to existence in the first place. You see, it's an 867-foot rock formation with walls so steep they're basically vertical. But that isn't even the main thing. This piece of stone just rose amid rolling plains of Wyoming with nothing like it for miles and miles around. So how is it that such a flat landscape could have suddenly given birth to something so tall? Theories abound, but nobody has the answer yet. My theory? Well, perhaps here is where the Earth has a giant outie belly button. Well then, you come up with a better theory. Oregon Vortex, USA. The House of Mystery in Gold Hill, Oregon amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. And there's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in this shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoided approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place and spread the news about it in newspapers and later on the internet, and voila, a perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Hudson Bay, Canada. Okay, we've talked about some pretty ambiguous stuff, but now it's time for the real deal, the Hudson Bay anomaly. This is probably the only place in the world where gravity is indeed lower than anywhere else on the planet. Even skeptics can't smirk at it because the difference has been measured with precision equipment. So, does it mean that the gravity here is as low as, say, on the moon then? Unfortunately, or is it luckily, I'm not sure yet, the difference is minuscule. The exact value is 0.005%, or 1/200%. You won't be able to feel it even if you try your hardest, but it's still there. Scientists say this anomaly exists because of the ice sheet that covered the area about 10,000 years ago. It compressed the rocks so much that they still can't fully recover, shifting the gravitational field in Hudson Bay. Sometime in the future, though, the gravity will return to normal in this area as well. No moonwalk for me then.
I'm about to introduce you to a place where the laws of physics take a vacation. Welcome to the mystery spot, where you can witness all kinds of implausible things that will leave you scratching your head in disbelief. Don't worry, it's not sorcery or witchcraft. It's just some clever optical illusions that mess with your brain and make you question reality. Back in the day when the Great Depression was hitting hard, people needed some fun distractions. That's how the entertainment industry gave birth to the concept of mystery spots. One of the most famous mystery spots is the one near Santa Cruz, California. The name is all intrigue and mystique, isn't it? Once you step inside, you'll see people standing upright on a slanted floor or at impossible angles on a flat surface. You'll see a ball rolling up a ramp defying gravity and logic. It's like being in a funhouse but without creepy clowns. The site is known for its gravity-defying demonstrations, which appear to bend the laws of physics, both on the short uphill walk and inside the wooden building on the site. Misperceptions of the height and orientation of objects occur here. These visual illusions include balls rolling uphill and people leaning farther than normally possible without falling down. Psychologists at Berkeley state that all of the misperceptions stem from the simple fact that the house is slanted at a 20-degree angle. The next stop is again in the USA, but this time at Hoover Dam in Nevada. Here, gravity seems to play with us too. Try this experiment if you ever happen to go there. Pour water from a bottle over the dam. You will witness that instead of going down, the water will start flowing upward. The reason behind this is a very powerful updraft that the structure of the dam creates. In other words, the water gets carried upward by the wind. This trick is not unique to the dam, as there's a reverse waterfall in the Faroe Islands. It occurs due to a wild weather phenomenon known as an inverted waterfall. Imagine a gigantic whirlwind of ocean spray swirling up a steep, 1,542-foot high rocky cliff. So how does this crazy phenomenon happen, you ask? Well, it's all thanks to a spiral column of air that rotates near high and steep cliffs, creating a mini tornado effect. And when the wind hits the edge of the cliff, it gets even stronger and picks up coastal water, which then splashes up the cliff and creates a massive water and wind funnel. Apparently, these inverted waterfalls can happen in other places too, like on the cliffs of Moher in Ireland, the mountains of Iceland, and even in the Waipuhia Falls of Hawaii. Talk about Mother Nature showing off her skills. Magnetic Hill in Ladakh, India? The ultimate mind-bending road trip destination? Here, you can watch objects and cars roll uphill like they're stuck in some kind of magnetic vortex. It's an optical illusion that occurs thanks to the sneaky slopes and general layout of the area. The road might look like it's going uphill, but it's actually a downhill road in disguise, playing tricks on your brain like a mischievous magician. You might also see your car moving by itself in the neutral gear. No, your car isn't haunted. It's just basic physics at work. Even when the engine is off, the wheels can still turn, thanks to momentum and the subtle slope of the road. Mount Aragats has a similar story to the Magnetic Hill of India. This one, too, is like a magnet for thrill seekers and car enthusiasts. It's located on the border between Turkey and Armenia. It has a reputation for making cars defy gravity. People from all over the world visit this mountain to witness the incredible spectacle, where a car parked on the slope seems to roll uphill all by itself without any driver behind the wheel. There's a nearby river that flows uphill too. People who visited this site claim that it's easier to go up than down there. Number 6 on the list is the Golden Boulder from Myanmar. The rock looks like it's about to tumble down the hill at any moment. But it's not going anywhere. It's been sitting there for over 2,500 years. The rock is the centerpiece of a stunning pagoda that sits on top of it, towering 49 feet above the ground. According to legend, the rock is held in place by none other than a strand of Buddha's hair. It's no wonder that this place is one of the most important Buddhist pilgrimage sites in Myanmar. The rock was chosen by a celestial king who was impressed by a Buddhist monk's incredible asceticism. So, he used his supernatural powers to carefully place the rock in its current spot, where it looked like the monk's head. If that's not enough, it's said that only a woman can move the boulder. That's why women aren't allowed to touch it. So, if you're up for an adventure, head over to this magnificent rock and pagoda and witness this gravity-defying feat for yourself. Back to the US. Oregon Vortex is located on Sardine Creek, Oregon. It's a tourist attraction that's been around since 1930. The owners of the attraction claim that it's some paranormal activity, but it's pretty obvious some clever optical illusions are involved. Legend has it that even before the attraction was built, Native Americans in the area warned that this land was forbidden, and horses refused to go there. But then, some gold miners built an assay office there in 1904, and the building ended up sliding to a wonky angle. Now picture this. You're in a cozy spot, away from city light pollution, staring up at billions of stars putting on a sparkling show above you. But if you're lucky enough to be in Marfa, Texas, you'll get a little something extra. Mysterious orbs decide to join in on the fun, shining bright like a diamond, and they've been doing it for over 100 years. But what are these glowing orbs called Marfa lights? Well, everyone has their own theories. Some people think they're just car lights from the nearby highway, but that's no fun. Others believe that these orbs are actually sentient beings trying to convey some sort of important message to us, mere mortals. Imagine standing at the edge of a stunning lake, admiring the picturesque view of a majestic volcano. Suddenly, you hear a loud boom and flames shoot up into the air like a fireworks show gone wild. But don't worry, it's not an eruption, it's just the Kawah Ijen lake and volcano doing its thing. This fiery spectacle is caused by a natural phenomenon where sulfuric gases burst through the rocks and ignite upon contact with the outside air. The result? Flames that soar up to 16 feet in height, burning blue like the coolest neon lights you've ever seen. And if that's not enough, the liquid sulfur that streams down the mountain looks like a molten river of electric blue lava. It's equal parts terrifying and breathtaking, and a sight you won't soon forget. Speaking of unforgettable things, the Richat structure in Mauritania has been an eye-catching enigma for astronauts since the dawn of the NASA space program. This circular feature in Earth's crust was created by a raised dome that was eroded over time, revealing the original flat rock layers. As you move from the center of the structure outward, you travel back in time, as the older rock layers are exposed in the middle. This geological phenomenon is made up of sedimentary and igneous rocks and measures 28 miles across. From space, you can see several faults where the rock layers have shifted and have been pulled apart. The Richat structure is situated in the heart of the Sahara Desert. There you go. This is our version of the top 10. Would you add something else to this list?